So the method we used last time of making a table can be used in other situations. And so let's do a couple examples here. Let's say this is a game. Maybe it's at the local shopping mall. Maybe this is a little pointer here, and this is kind of a spinner that you spin. You get up and you spin the spinner, and then it stops either at $1, $5, $10, and $20. And it has the same chance of stopping at each one of those. And let's say you get to go up front and you get to spin the spinner twice. And then you get the total amount on both spins. And you want to know how much money you could earn, or the probability of earning, let's say, $2. So the least you could earn is $2. The most you could earn is $40. So what's the probability of earning $2 or $15 or $20, $30, whatever? Okay? Well, what you can do is you can make a table, and it's going to be a 4x4 table. And you can think of this as spin 1, just like roll 1, and this would be spin 2. Spin 2. So you could spin a 1 and a 1, and that's where you get the $2. A 1 and a 5, you would get $6. 1 and 11 would be $11. 1 and 20 would be $21. So this would be 6, 10, 15, 25. This would be 11, 15, 20, and 30. This would be 21, 25, 30, and 40. So you have these different possibilities then. And so you could ask questions like, what's the probability that the amount of money you make is going to be greater than or equal to $20? Okay, so again, there's 4 times 4. There's 16 outcomes. Right? So the bottom number here would be 16. And then how many of these are greater than or equal to $20? So you would have 1, 2, 3, 4, 5, 6, 7, 8. So you would actually have a 50% chance of making more than $20 on your 2 spins. And you could ask other questions as well. Okay, so this is an example where you're actually doing something very similar to rolling 2 dice, but you're kind of applying it to something different. Here's another one, and this one's good because now you're not even doing the same thing twice, like rolling the same dice twice or spinning the spinner twice. But this is, you're going to go to a movie and do an activity. So on a date. I'm sorry. You're going to go to dinner and then do an activity. And there's 4 restaurants that you like to go to. And these are the prices of those 4 restaurants. And there's 3 activities you like to do, and these are the activities. And then you could say something like, we're going to put the 3 restaurants or the 4 restaurants into a bag, and then the 3 activities in another bag, and I'm going to randomly select a restaurant, randomly select an activity, and you want to know what's the probability your date is going to cost more than $50, strictly more than $50. So that the money is strictly not greater than or equal to, but strictly more than $50. Okay, so the dinner would be these. The activities would be these. Okay, so 10, 15, that'd be 25, 35, 50, 75. This would be 40, 50, 65, and that would be 90. This would be 65, 75, this would be 90, and this would be $115. And so now if I wanted to know how many are greater than or equal to 50, well, this square is like 4 times 3, and that's going to be 12 outcomes. So my bottom number is 12. And then greater than or equal to 50, there would be 1, 2, 3, 4, 5, 6, 7. I'm sorry, not greater than or equal to. This was strictly greater than 50. So it would be these dates are strictly greater than 50. So 7 out of the 12. And that's like approximately 0.5833. That'd be the probability that it was strictly greater than 50. That's just an example of showing you how to use this same method for whenever you're doing two different things. A combination of two different things. You can set up a table like this. So in the next video, I got an activity for you to try similar to this.